Okavango is a landscape of rivers, wetlands, and grasslands that interlace across Central Africa. During the seasonal flood, herds of buffalo trample the grass, elephants cross channels, crocodiles hold in ambush, and migratory birds move in extended flocks overhead. Within this active system, a small animal moves through reed beds. It is not an apex predator, and it does not hold the top position in the food chain. However, many species, including venomous snakes, lions, and hyenas, show caution when they encounter it. Its body stays low to the damp ground, and its eyes scan continuously. Each movement reflects strong survival adaptations and consistent readiness to respond. In the demanding conditions of the Okavango, where body size alone does not ensure survival, the honey badger demonstrates that outcomes depend on effective behavior and persistence. The honey badger is not large, but its body is optimized for survival on the Okavango floodplain. Its total length is about 3 feet, and its weight is usually under 33 pounds, and each body part supports defense and foraging. Its fur functions as natural armor. A coarse, silver-gray outer layer runs along the back and reduces abrasion and impact. Beneath it, a dense black layer provides elastic padding that resists teeth and claws. The skin of the neck and nape is loose and about 1/4 inch thick. This structure reduces injury from bites and allows the animal to rotate its head while held, which enables precise counterattacks to vulnerable areas of an opponent. The body is low-slung with short legs and strong muscles. The forelimbs carry long, curved, robust claws that act as tools for digging termite mounds, searching in compact soils, and breaking bark to reach food. In dangerous encounters, these claws function as weapons that can inflict deep wounds quickly. The main advantage of the honey badger is a balance between defense and offense. The double coat and thick skin protect it from direct strikes, while a flexible body and sharp claws enable immediate responses to threats. This balance is effective in the Okavango, where frequent interspecific conflicts make reaction speed critical for survival. The design also has limits. A low profile and short legs restrict top speed and reduce capacity for long-distance escape. The animal relies on surprise, terrain, and persistence to break contact with larger predators. Low body mass and small size reduce success in direct multi-angle attacks from larger species. Overall, the honey badger shows that a compact animal can occupy a strong ecological position. Its optimized build supports life from dry grasslands to marsh edges, and the mix of durable defense, efficient foraging tools, and rapid counterstrikes makes it a difficult opponent to manage. In a competitive system like the Okavango, the honey badger uses its senses and body plan to exploit food sources that few species can reach. Focused attention, accurate localization, and precise attacks make it one of the most effective small predators in this region. In the Okavango, many species depend on speed or physical strength to survive. The honey badger follows a different strategy. It does not rely only on sudden bursts of speed or superior muscle power. It depends on persistence, sharp memory, and the ability to adjust behavior after each encounter. Past experiences become data that guide future responses and reduce risk when it faces the same threat again. This strategy makes the honey badger unpredictable when it approaches prey or an opponent. It applies the method that has been effective in similar conditions. This behavior is important in the Okavango, where the environment changes each season and prey behavior also shifts with conditions. Another key feature is its high resistance to venom. Its body produces natural antibodies that can neutralize or reduce the effect of strong venoms, including those of cobras, vipers, and puff adders. This ability allows snakes, which are major threats to most animals here, to become accessible prey for the honey badger. In the Okavango, venomous snakes are a constant threat to many species. The honey badger turns them into an important food source. Hunting snakes is not only a way to obtain food, but also clear evidence of adaptation and use of unique biological advantages. When the honey badger faces a venomous snake, it does not attack immediately. It observes carefully and maintains a safe distance to assess movement and strike patterns. In open areas such as grasslands or cracked soil, its quick changes of direction and flexible body allow it to avoid fatal strikes. When the right moment comes, the honey badger accelerates and approaches from an angle that prevents the snake from turning its head to counterattack. The thick and loose skin around the neck reduces the chance of a lethal bite. If envenomation occurs, its resistance to venom prevents immediate collapse, which is a major advantage, compared with many other species that die within minutes. The ability to hunt venomous snakes provides the honey badger with food rich in protein and fat. It also reduces pressure from dangerous species within the ecosystem. By limiting snake populations, the honey badger helps maintain balance and indirectly increases survival opportunities for smaller animals. Its mix of biological defenses, combat skill, and venom resistance allows it to secure a strong position in the food chain despite its small size. This proves that in nature, success depends not only on strength, but also on strategy and specialized adaptation. The main strength of the honey badger is its ability to adapt. It can hunt in many environments and does not depend on a single food source. Its diet is highly varied, ranging from insects and reptiles to rodents and small birds. This diversity prevents population booms of specific prey species and keeps the ecosystem in balance. However, its impact has limits. Because it lives alone, the direct influence of one individual is not large. Control of snakes or insects is effective only in areas where it hunts regularly. Frequent digging can also destroy the nesting sites of some animals, forcing them to move elsewhere. Despite these limits, the honey badger remains a valuable link in the chain. It is both a predator and an accidental engineer that creates new habitats while reducing the spread of species that may disrupt balance. Its absence would cause major changes in population structure and food chain dynamics. In the Okavango Delta, it is not always the large animals that maintain natural order. Sometimes, small and often overlooked species like the honey badger play the key role in keeping the ecosystem stable through the cycle of wet and dry seasons. In the flooded plains of the Okavango, the environment changes with the seasons and challenges every species. The honey badger continues to survive without overwhelming strength or support from a group. Its main advantages are strong defense, sudden attack speed, and thick skin that reduces injury from large predators. It holds its place in the ecosystem through an active survival strategy. Its aggressive defense forces many predators, including lions, to reconsider before striking. Hunting venomous snakes provides not only a rich food source, but also reduces threats to other species, helping maintain ecological balance. However, these advantages do not remove all danger. When facing groups of predators or fighting in confined spaces, its ability to evade and react decreases. Its muscle strength is also insufficient for extended combat. The honey badger is a small but effective link in the Okavango food chain. It does not stand out through size or strength, but through persistence in every encounter. This resilience shapes predator-prey relationships and helps maintain the stability of the ecosystem in this harsh environment. In the Okavango, when floodwaters cover the grasslands, the red lechwe gains a natural advantage. Its long hind legs, flexible joints, and wide hooves spread body weight and reduce sinking. Its coat carries a light, oily layer that lowers water resistance. The red lechwe cannot outrun open plains antelope on dry ground, but in mud and shallow water its long leaps and splashing strides allow steady speed and mid-range escape. Red lechwe usually gather in large herds across shallow floodplains where predators hesitate to chase. Their escape routes cut through deeper channels that stretch and break predator formations. When pressed, the herd turns sharply together, throwing waves of water and mud that disrupt sight and scent. This tactic is effective against wild dogs or hyenas on firm ground, but it loses advantage at river crossings where crocodiles wait. In the wet season, dominant males hold territories on raised ground and display strength through short chases. Open ground provides early warning of predators, but also makes them visible from long distances. Calves are born at the edges of flood meadows where dense vegetation hides them. But proximity to water forces mothers to balance concealment with escape routes. By grazing selectively on flooded grass patches, red lechwe maintain a mosaic of vegetation that creates access for water birds and aquatic insects. When they cross rivers, they transfer energy from grazing grounds into aquatic food webs, creating pulses of nutrition for crocodiles and fish. Within the Okavango, red lechwe serve as a living link between dry grasslands and the seasonally flooded plains. Nile crocodiles occupy channels, sandbanks, and access points where animals come to drink. Their flattened bodies with eyes, ears, and nostrils placed high allow near total concealment beneath the surface. Thick armored scales protect their bodies, while the muscular tail delivers bursts of power over a few decisive yards. They wait patiently for weakness instead of engaging in long pursuits. Along the jawline, pressure sensors detect the slightest vibration from footsteps, ripples, or splashes. When prey enters range, the crocodile drives forward with a tail surge and clamps its jaws sideways to lock the target. Then twists violently to tear tissue. For lechwe or young buffalo at crossing points, a single misstep can mean being pulled under. In the dry season, females dig nests on sandbanks above flood level. And choose sites with stable temperature for eggs. Mothers guard the nests and assist hatchlings into the water. Crocodiles regulate body temperature through cycles of basking and immersion. When rivers shrink, they gather in remnant pools and shift to feeding on fish and carrion, recycling nutrients within the channel. At the water's edge, the balance of power changes with depth. Lions or hyenas may steal kills from crocodiles on land. But once half the body is back in the water, advantage returns to the reptile. This tension keeps river crossings as high-risk zones where strategies shift with seasonal water levels. Through ambush at crossing points, Nile crocodiles channel the energy of migrating herds into aquatic systems. Uneaten remains, bones, and tissue fragments feed microbes, fish, and water birds. They act both as dominant predators and as nutrient recyclers, keeping the wetlands functioning as a closed system through cycles of flood and drought. In the channel maze of the Okavango, African wild dogs operate through precise formations. Small packs of 6 to 15 individuals center around a breeding pair. At dawn, they set hunting routes by scent carried on the wind across grasslands and flood margins. Their lean bodies, long legs, and narrow feet are built for distance running. Mottled coats break up outlines in tall grass. They cannot match the sudden sprint of a cheetah, but they maintain relentless speed over distance to exhaust prey. When approaching herds of lechwe or impala near water edges, the pack splits into flanking units to block escape. Lead animals drive prey into open ground, while side groups force them toward floodplains. Each chase has a handoff point where a trailing dog takes the lead to keep pressure constant. High-pitched calls and raised tails coordinate spacing. This method is effective in shallow marsh, but less so when deep water favors swimming antelope. Wild dogs prioritize food sharing. Pups and injured members feed first, and other adults regurgitate partially digested meat for them at the den. This distribution reduces local shortages and sustains the pack's high hunting frequency. Dens are dug on high ground with multiple exits. As floodwaters rise, packs relocate to safer sites away from crocodile corridors. Their greatest limitation is water depth. Deep marsh slows speed and breaks formation. Competition from lions and spotted hyenas at kills further reduces returns. Even so, with frequent hunts, wild dogs regulate medium-sized antelope populations, removing weak or diseased animals and reducing grazing pressure. In the structure of the Okavango, they are agents that maintain the health of herds across the transition from dry ground to floodplain. The hippopotamus is a semi-aquatic mass of muscle with thick skin that secretes a protective fluid to reduce water loss and shield against ultraviolet radiation. Its eyes, ears, and nostrils sit high on the head, allowing breathing and observation while the body remains submerged. During the day, it rests in deep channels to regulate body temperature. At night, it moves onto grazing grounds. Leaving well-defined trails that connect water to grasslands. The movements of hippos carve channels through flooded vegetation. Opening passages that allow water to flow between swamps and rivers. Their waste is deposited along these paths, providing nutrients for microbes, insects, and fish. At moderate levels, this input increases aquatic productivity. When densities rise too high, the accumulation of organic matter reduces oxygen and creates localized ecological stress. Adult males occupy pools and establish territories with open-mouth displays and deep bellows. These boundaries often overlap with water access points used by other animals, raising the chance of conflict. On slippery banks, hippos struggle to change direction quickly. In deep water, their buoyant power makes them dominant. Crocodiles avoid direct confrontation with healthy adults, but may target calves when they stray from their mother. Hippos transfer energy from night grazing grounds back into daytime waterways, linking two major food webs. They open corridors for small fish, water birds, and otters to use. Yet, when populations cluster too densely, competition for grazing space increases and aggression rises. In the Okavango, the hippopotamus is both an ecosystem engineer and a source of disturbance, maintaining a shifting balance tied closely to the seasonal rhythm of water. In the flooded plains of the Okavango, the environment changes with the seasons and challenges every species. The honey badger continues to survive without overwhelming strength or support from a group. Its main advantages are strong defense, sudden attack speed, and thick skin that reduces injury from large predators. It holds its place in the ecosystem through an active survival strategy. Its aggressive defense forces many predators, including lions, to reconsider before striking. Hunting venomous snakes provides not only a rich food source, but also reduces threats to other species, helping maintain ecological balance. However, these advantages do not remove all danger. When facing groups of predators or fighting in confined spaces, its ability to evade and react decreases. Its muscle strength is also insufficient for extended combat. The honey badger is a small but effective link in the Okavango food chain. It does not stand out through size or strength, but through persistence in every encounter. This resilience shapes predator-prey relationships and helps maintain the stability of the ecosystem in this harsh environment.